Okay, so back with the scholarship questions. It's a little bit later in the year. We've skipped 3 weeks in calendar time, but the questions are still the same. And so with these remaining questions, I have seen them before, so it's slightly less authentic, though I have to emphasise our baby kept us awake all weekend. So I'm a bit exhausted, so that might compensate for the fact that I've seen these before. A bit more realism to that. Okay, so we're looking at question 2, which is conveniently labelled inductance. Remember, just pay attention to those titles of questions because they can help you. Not always, but they can do. A 75-watt electric light bulb with zero inductance is designed to run from a 50 Hz AC supply of 120 volts RMS. If the only supply available is 240 volts RMS and 50 Hz, the bulb can be operated at the correct power by placing in series with it either a resistor or an inductor. And part A, find the values of the resistance and inductance and the power drawn from the supply in each case. So this is a AC circuits. So what I would start by is just sketching the situation we have. So what we should have is a bulb. Now I'm just drawing it as a resistor because that's all bulbs are, they're resistors. 120 volt supply, and we should get 75 watts from the bulb. That's how it's designed to run. Bulbs I've drawn it as a resistor there. It's worth remembering bulbs don't obey Ohm's law. They're rather non-linear, and that's because as you walk around through them, they heat up, their resistance increases. Okay, so what we want to do, we'll do part 1 first. We'll put in, so we only have a supply that does 240 volts. So let's call that B for bulb. So what the question says, we can put in a resistance in series R, here's our B bulb, and still have 75 watts over the bulb. No, 75 watts power dissipation at the bulb. Okay, so find R. So if the bulb has the same 75 watts across it in this case, and in this case, what's obvious is that it must have the same voltage across it. I mean, power is just voltage times current. The current through it is related to the voltage across it. So you have V squared over R. Remember that V is not the 240 volts, it's the voltage over the bulb times the resistance of the bulb. So to get these to stay, what we would need to do is make sure there's 120 volts across there, which tells me that the answer is fairly obvious because we've got double the supply voltage here. To get 120 volts here, we'll need 120 volts here, which means, so if we make R equals R bulb, then 120 volts across both, and that thing will operate at the right power. Okay, that's your resistance. And it also says in the question, what is the power drawn from the supply? Well, since we're running this at 75 watts, this one will be doing 75 watts. This one is identical, it's another same resistance, so this one is going to be 75 watts. So power drawn equals 2 times 75 watts. equals 150 watts. So it's not a terribly efficient way of running your bulb off 200 volts. You're wasting half your power there.
Just a quick point, do we need to, what is the question asking us to find? Is it want the specific value of the resistance? Can we calculate that?
Okay, right, so that's a good point. Yes, reading question. Find the value of R. We found the power drawn, we haven't even found R, and we can still find the power drawn. Yeah, read that question. So what is R? So if we know 120 volts gives you 75 watts, then so 120 volts gives 75 watts. Then current, what do we want? We want this one here. So V squared bulb over R bulb equals 75 watts. So we know the voltage, 120 volts. We want our bulb, so that implies that resistance of the bulb is V squared over 75 watts equals 120 volts squared over 75 watts. Squared divided by 75 is, on my calculator's display, it's gone a bit strange.
I'll just quickly calculate it for you.
Yes, I know the battery's going on that. Sam's pressing the buttons.
192.
192 ohms. Okay. So that gives us a resistance. So we found the resistance, we found the power